Well, Raul, you want to go ahead and give the technical update?
Yeah. So here is a link to the technical update in the chat. And let me share my screen. Okay. So in terms of the releases, we're still testing the 0926 last finalized state release candidate version. We are expanding the amount of testing on that on the testnet, and Gurinder is now in the process of making all the testnet nodes use the LFS. And Tomislav is adding a few more tests to the last finalized state, and we'll be doing another release of it, but it's just additional tests is what it is at this point in time. And then the mainnet is running 0925.7, which is the same as before. And as far as development is concerned, again, our focus is getting 0926 last finalized state on the mainnet, continue the block merge work, and the Rolang 1.1 as the main streams of work, and resolve any bugs that we identify, and then harden the mainnet in general, or look for performance improvements. The library updates mostly are done for now. We have still a few more we will do, particularly around the monitoring stuff, and then we will we'll catch the rest of them as we go. Now, we have made quite good progress on block merge. There are a couple things here that I'll speak to. Like I said many times earlier, Will and NutZipper were working parallelly. NutZipper was working on the merging side of things to say, you know, what all is involved, what all pieces of code are involved in merging, and making sure that that works smoothly, whereas Will was working on resolving conflicts between blocks. So on the block, and now where we are is basically Tomislav is winding down the last finalized state, and he's joining Will on the conflict resolution side. So that's where the team is focused in terms of relative effort. And we have had different cases that we were discussing for, I'm not sure if folks remember, but there's a whole spreadsheet of conflict resolution that was created a while ago, and Will has been working through that and has been discussing the cases. Greg has formulated a simpler way of dealing with all of them in a simple formulaic manner. And Tomislav and will implement that methodology. There are two stages to it. The first stage is not dealing with joins, but then Greg is writing up the methodology for when joins are involved, and that'll be the second stage of the implementation of this. There is another thing that was discussed, which is still being investigated, about how the libraries in the registry may cause conflicts, and we are investigating whether parameterizing them on channels would reduce conflicts. So that would also substantially add to that. And of course, I think anytime you parameterize on the channels, there may be a little bit more use of the memory, but all of that will be something that we'll be looking into when we start looking at that. Meanwhile, while resolving or working on this block merge, NutZipper has discovered a bug that seems to be a peak bug. We are trying to understand. He has seen that by changing that in some contexts, it seems to work, but we have to really analyze the behavior of that across the system, because peak is used in many different places. So we have to see what is the right approach to that, and then we'll have an appropriate fix for that at that point in time. what triggered that investigation was partly a slashing we had seen on the mainnet. Now, since the co-op is controlling all the nodes at this point, anytime we see a slashing error, it's basically a code-based error that we need to resolve. So they're investigating the source of that bug is one thing that we're doing. But the other is that if a node is slashed, then we have this whole quote unquote scut work we have to do to bring down the nodes, restart the nodes. It's a lot of wasted effort. So what we're doing is NetZipper put in a PR 3259, which is a temporary fix that lets the network continue. Basically, it prevents the node where the tuple space error is observed. That node will not put out that, create that block, so that the network can continue. But we will have record of the tuple space error, so we're able to look at the state and the and what happened before then that caused the tuple space error. So it'll be much easier for us to deal with or analyze the issue than having to kind of scramble, especially on the mainnet. We don't want to bring down the nodes too often and having to create nodes again and have them catch the state and all that kind of stuff. So this is a temporary fix. Obviously, this won't work when we have external validators. So we should be removing this well before then when we start testing for scenarios for external validators. But this is something for now is more of an efficiency measure. So we don't have to, so we can eliminate the eliminate the unnecessary work and stay focused on resolving the bug. So that's kind of where we are on that. So the goal with block merge in the, we will be releasing it in small doses to the feature branch and probably do some release candidates starting soon, probably in the next few weeks. And then once much of that is done, we'll probably do a demo of how that's working. The Rolang 1.1, Joe has his first PR, the 3262 PR, and he completed the implementation of let syntax and the tests. And I think he's right now resolving some of the tests there, and also beginning to work on synchronous output. Now, Rolang 1.1, again, will probably do in small dose release candidates on the feature branch. This is one thing especially we want the community to test out as early as possible and as often, so that we get a good amount of testing on it and Joe gets some early feedback on this, because by the time he's done with it, we want to be in a position where we could deploy it on the main network sooner than later. Now, deploying Rolang 1.1 is not that simple. Eventually, we may have to change all the internal contracts, the system contracts, to be able to use the 1.1 syntax to really get the benefits of the syntax. And before that even, there's the whole performance optimization we need to do on Rolang 1.1. But it is, when it comes out, both for the system overall as well as the end users and dApp developers, for the dApp developers, it's going to be a good improvement in terms of how things work. So I want people to get comfortable with testing and using that, so that we are, both as a community and as a platform, we are equipped to use it sooner than later. So that's the thinking with the Rolang 1.1. I think those are the main changes, our main things to report. There's not much change on anything else. Are there any questions from anybody on what I covered? All right, over to you, Greg.
All right, thank you, Rao. That was quite good. Just to amplify a little bit what Rao said about the block merge. We can write down the merge conditions pretty straightforwardly. I'll do a quick screen share. So I just wrote this up while Rao was giving the update. That shows you how simple it is. So essentially, it turns out that all the state associated with the blockchain while it's stored in the tuple space, there's a one-to-one correspondence between the tuple space state and a Rollang expression. So that Rollang expression can be written like this. So it's a big par. So this pi means a lot of pars. So it's a big par of 4 comprehensions in parallel with a big par of outputs. That's essentially all that's being stored in the blockchain state. And we have a guarantee, and the guarantee is that for all ij, there's no interaction with the xi's and the uj's. So now there's a little bit of sophistication around this with respect to joins, but it turns out that you can always translate the condition with the joins back down into a join-free state. So that's just a theorem that we have lying around. So this is the blockchain state, and now what we're looking at is whether or not we can merge block 1 and block 2 on top of the blockchain, on top of the block state. And essentially what that means is we treat this as a Rollang process. We put that in par with the parallel composition of these two. And if that is race free, then it's okay to merge these 2 blocks. So by race free, what we mean is if X is in the free names, so XI is free in this forward comprehension and UJ is free in this output. So if X is in the free names of the block state, intersected with the free names of the 2 blocks we're considering merging, then what we need to look is at the occurrences of the negative and positive polarities. And essentially they have to line up. That's what this notation means here. So if it so happens that we have an X in a positive polarity, so that would be like an output, and 2 X's in the negative polarity, so 2 forward comprehensions sitting at X, then you have a race. And so these two are not mergeable because you have a conflict. If it goes the other way, so you have 2 outputs and 1 input, then you would also have a race. So this is a simple syntactic check that you can make in near linear time in the length of the list of free names. So that's all that has to be checked. So rather than write a bunch of complicated conditions that have to be checked, we have one condition that's checked, and it's a relatively efficient check that can be done in very, very good time. So this is the formulation for the non-join case, and then the join case is just a little bit of sophistication on top of this. It's not particularly not extra complicated, and I leave it actually as an exercise for those people who want to kind of flex their Rollang muscles to do the join case you know, before the next stand up, because by then I'll have written up the join case as well. But if you wanna like get your hands dirty, write a little Rolang, or prove something about Rolang. Now, the thing that's really interesting about this is Will was following an interesting intuition, which is that if you're able to calculate a diff, so like with if you think of B1 and B2 as something where you can calculate a diff, like a pull request and get, for example, then you could check to see if you know, if you merge B1 and calculate the diff, and then merge B2 and calculate the diff, if that's the same as if you merge B2 and then B1 and calculate the diff, right? If the diff is the same, then you know you're good. But the nice thing about Rolang is that we don't have to calculate the diff. So this is a simple syntactic check. The whole point of block merge is that we're not running this code again. Obviously, we have to run it once to run the block, but when we're doing the block merge, this is about replay. And what we don't want to do is to replay these blocks, or we want to get away with as little replay as possible. So we don't want to have to calculate the diff. And what this is showing is that we have a simple syntactic check to see whether or not they're mergeable. And that's the advantage over another state machine based approach or anything else. We're not running the code again. Whereas to calculate in the arbitrary diff case, you have to run the diff calculations in both directions. So that's why this is faster. Any questions about this?
I have a question.
Yes.
So I'm just wondering what the context is of this. Like, why are you explaining this right now?
Oh, because a lot of people are very, very interested in block merge, because once we have the block merge feature, we are going to be running much faster.
Oh, so this is completely relevant to how block merge works.
Yes, what I just gave was a reduction of all of the different cases that Will was calculating to a single check.
Okay. All right, thanks.
Yeah, so Will was writing a bunch of if then else checks, and I boiled it down to exactly one check that we know the complexity of. We know that this complexity is much smaller than rerunning the code. So that's the point. And you can see that the complexity is smaller than rerunning the code. It's self-evident, and you don't even have to do a sophisticated mathematical proof. It's like self-evident that the complexity of doing this is far below rerunning the code.
So, and because of that, it just makes
it allows you to see, it allows you to see exactly why this is scaling in this particular case.
Right. Okay.
So it might help if I make a graphic. So what we're saying is, here's the base state, and here's block 1, and here's block 2. And what we're asking is, do I have to put these in a particular order, or can I merge them onto the state in parallel? And you want that check to be shorter than, well, I'm going to merge this one and then I'm going to merge this one, and check to see is that the same as if I merge this one and then merge that one? Right? Because if I do it, if I have to make those checks, it says it would be much faster just, you know, pick an order and you know, chain them together. Does that make sense?
Yes.
Right. I mean, it's a very simple graphic, right? Right. What I'm asking is, this versus, so let me give these names. So this is the base state. Here's block 1 and here's block 2. And now what we don't want to have to do is to check that followed by that, right? Let me just pull these down a little bit or just move them over. We don't want to have to do that calculation and this calculation here. And check to see if they come out the same. Because if I have to do that, it's much faster, just pick an order and do that. But if there's some fast way to check it's all safe to do this together, then it's much, much faster to do the DAG. And what I just showed was, here's the syntactic check that is near linear time. It might be quadratic now that I think about it, but it's quadratic in the length of free names, which is very small. So that's the trick. And this is kind of the point we've been trying to make about Rolang for quite some time now.
So Greg, about the if you put something that indicates that's what race-free definition is, that might help people that are watching the.
Yeah, this.
I mean, you said it verbally, but I'm saying just from a presentation perspective, people can. It'll be easier for them to follow. Yeah.
Sure. There we go. So there we go. That's the idea. And this kind of thing, this kind of syntactic analysis is at the heart of what this behavioral types do as well, right? See, I'm doing this kind of check just by inspecting the syntax of the Rolang. So here I have an arbitrary syntactic form, right? When I have a syntactic form like this, I can just go and inspect a syntactic form for certain kinds of properties. Well, here's a property. This is a guarantee that we always have of the tuple space, you know, we know this to be true of the tuple space. This is what it means for the tuple space to be consistent. But you can do these kinds of syntactic checks and checking for properties for arbitrary contracts. This just happens to be an example of one of the kinds of things you can do. But you know, more specifically, we can do all kinds of sophisticated checks just by inspecting the syntactic form of the contracts without running them.
Okay, so earlier today, Dan Connolly kind of explained an analogy to me that I'm not sure whether it applies to what you're talking about, but it seems like it is. So I'm going to shoot by a very bad paraphrase of his analogy and see if it makes sense. So his analogy was like, let's say that you want to drive your car from point A to point B, and you're using Ethereum. So you get in your car and you hit the first intersection, and there's a crossing guard there, and so you have to get out of your car and you have to show your ID to the crossing guard, and the crossing guard goes, "Oh yeah, that's you. Now you can turn left." And then you turn left, and then you hit a parking lot, and you have to get out of your car and show your ID to the parking attendant. And the parking attendant goes, "Yeah, okay, that's you." And you get back in your car and you park your car. And it's a very cumbersome process. Right. Whereas with RChain, the process is, here's your keys, drive your car.
Something like that, yes.
Okay.
It's a like this one-time check is more like having the traffic lights be smart.
Okay.
Right. So you've probably driven in cities where the traffic lights are smart about traffic density.
Yeah.
Right. So that's what this check is like. It's like having a smart traffic light.
Okay.
All these running the same direction, and there's no traffic on the other one, keep the light green.
Okay.
That's the way to think about it.
Is this anything like having a behavioral type for race-free code?
Yes, that's what I was just saying. That's exactly what I was saying.
A behavioral type for race-free code.
Right.
Okay.
We're literally checking to see if this collection of code is race-free. That's precisely what we're doing.
And then if it is, it's you get
If
the
it's-
green light.
Then you get the green light. And so both of these blocks can build on top of the base state without introducing problems.
For example, if Alice sends 20 revs in B1, and if she also sends 20 rev in B2, it might not be race-free, right?
Correct. That's exactly right.
Well, thank you.
No, thank you. I appreciate the opportunity to explain this. So with that, let's turn it over to you, Darryl, so you can give the community in review.
Oh, okay. Just let me switch my screen here. Okay, so here's the week in review for the 3rd of December to the 9th. Last Thursday in the governance committee, they discussed alternative conference platforms such as Big Blue Button through meet.coop. There's no recommendation at this time since the requirement for mobile app, support dial-in, and share recording are not met. We discussed elections for governance committee members in the future. This is currently not recommended. And finally, there was a continued discussion from last week on bounty pricing guidance. On Friday at the Climate and Coordination Call, we had a guest named Ward Sturrat. He's a Canadian decentralist and entrepreneur. We discussed the fires and power shutoffs in California, soil as a carbon sequestration solution, and Ward also spoke about his work with the projects Transcarbon and Credits. On Saturday, there was a COVID-19 digital ID accreditation wallet meeting. And on Monday, there was another one. And that one was mainly a prep for the doctor's meeting that was coming on the Wednesday. Also on Monday was Casper Standup. Greg and the group discussed quantale valued relations as a means to extend the container logic to linear logic. Also on Monday was the RDev member group planning call. They welcomed Sean, who plans an active role in RDev. They focused on planning both robot and HTML5 vote interfaces for liquid democracy. And they discussed funding methods for productizing the prototype and considered wrapped Rev development for trading on Uniswap requested in Reddit. On Tuesday, in the communications working group, the conversation mainly revolved around how to effectively message the reason why Dazzle should be built on RChain's Layer 1 platform. Also on Tuesday in the DApp developer working group, they reviewed liquid democracy status and investigated node building, sorry. Let's see, today, there was another digital accreditation wallet meeting, this time with feedback from doctors. And also just an hour ago at the RChain Active Member Hangout, we looked at the current RevDefine issue and then examined some other blockchain identity projects that are focused on medical records. And then we discussed getting the message out about RChain's uniqueness. Then Raphael joined the call and announced a new update for DAPI. Raphael and Dan had discussed MakeMint, a pattern using object-oriented programming, using object capabilities for our tokens. And that brings us to now.
Wunderbar. Thank you so much. I will also mention that we had a good discussion with a couple of doctors who have a relatively high profile in the UK and internationally on the digital accreditation wallet as it applies to COVID. So we walked through the scenarios as we understood them. And I think there was a general agreement. The design would in fact support the COVID scenarios from the point of view of the doctors. So that was very, very encouraging to have that kind of validation that the design matched with their domain-specific understanding. It raised some good and interesting questions with respect to partial reveals of information. But fortunately, at least with the COVID case, you don't have a particular need to do that, but it is an interesting direction for additional feature development should the work begin to take off. Any questions about that? Okay, then. I'm personally excited about it. I think it's one of the areas that we've been talking about quite a bit, where you have high value information stored on chain, and it's private information. And the decentralized nature of the data being stored on chain is important because you don't have to trust any particular authority, be it aligned with a national jurisdiction or otherwise. It's your data, and you're the only one with the access to it. And as a result, because of that specific property, there's not a lot of need for additional worries or concerns with respect to self-sovereign identity. It's an object capability design where the agent who has the private key is the one who can demonstrate the capability of unlocking the information on the wallet. And so that's all that's necessary. So I'm particularly pleased that we're matching up with the expectations of the physicians. I also want to give a shout out to Raphael and Theo, who've done already amazing work on pulling together code that is demoable enough to give credibility to the whole conversation. So kudos to them. All right, we had a special board meeting on Tuesday, as we normally do. And there was basically an informational meeting. So no decisions were taken yesterday, as far as I know. There were no votes taken. But there is some good thought that we will discuss in the closed door session on the basis of the last week's conversation. So that takes into account a lot of the discussion that was in Discord that NutZipper and others brought up. So please feel free to join us on Friday to see what the board has cooked up with respect to that. Anything else you think I should cover, Ian, Darryl, Rao?
There's the announcement that deposits for Epoch 3 staking, the deadline has been moved to Sunday. There's been quite a lot of interest, and the deposits right now, including what is pledged, it's nearly 10% of all of the rev. So right now it's getting up in the neighborhood of around nearly 70 million rev.
Wow, that's really, really impressive.
Well, maybe 65, maybe more. It depends if what pledges come through.
That's really great. That's great news. That's really great news. Yeah, I'm excited. Yeah, I think staking on RChain is only going to get more and more interesting. I also want to mention before signing out that there is a GitHub gist that was mentioned on Twitter. So someone watched the Casper stand-up in which I talked about the esteem calculation and wrote a Rust gist of the esteem calculation. So we were successful in communicating the idea so that someone else could reduce the idea to code, which is great news, because that means again, it's an objective idea, so we can communicate it, people can absorb it, and they can present back to us in the form of a executing Rust code what it was that we were what we were talking about. So I count that as a big success, and again, another confirmation and validation of the kinds of designs that RChain is all about. And in particular, what Dazzle is all about in this case. All right, any other questions, comments, concerns from the community? Okie doke. Thanks so much. I hope everyone stays safe, and we will hopefully see many of you on Friday. Ciao for now.